Hi everyone. Today I'm going to be talking about science in general and about how to what it means to have a faith-based science program for teens specifically. So at Arise, this is something that we really feel passionately about, that our classes are Christ-centered and it is a place where Christian teens can grow, can learn, and have their faith strengthened. So, with regards to science, what does this mean to have a faith-based science? So, St. Augustine was famous church father and theologian. He first came up with this idea that there are two books. There's the book of scripture and there's the book of nature. That in the created world we can understand and see aspects of God's character. And by studying science, we can learn more about who God is. And I really believe that is true, and others throughout the ages have picked up on this idea. And most of you will know that many of our really great scientific minds down through the ages were devout believers, like Newton and Michael Faraday, for example. They all saw their faith as being instrumental to their work as scientists. So this idea of faith and science being against each other is not true, and that we can learn about God from science, and our faith can really help us to practice good science. We know that Jesus is the way, the truth, and the life, and therefore, as the truth, everything that is true is pointing to Him. We think of Him as the truth, as the Word of God is truth, that what He says is truth, and that therefore, there are things that are true, and there are things that are false. This idea that my truth is your truth is your truth. It's false. That there are things that are true for me, like I like the colour green. Um, I like to drink tea. And your truth might be you like the colour red and you prefer coffee. And that is true. It's not like tea is the ultimate true drink and coffee is the ultimate true drink. These are um subjective truths, but there is truth that is just true. It's universally true. So when we're studying science, all true science should be pointing to truth. It is true for me, it is true for you, it is true for all people at all times, and therefore is points back to God, our creator, who put the world into order, who created a universe that is governed by laws and and um and things that hold everything together, the mathematics of the universe. I see science, not very much, it comes back down to the mathematics of it, that everything is underpinned by that mathematical model, and then from that the different laws of science kind of fall out. And it's all interconnected in that way, but ultimately it's all been instituted by God. And so we're going to be talking in another podcast about God and mathematics and how the laws of mathematics are, they point to God. But ultimately, those then define our science and how that is ordered and how it works together from the inner workings of a nucleus with those fundamental particles, the quarks inside a nucleus, and the interactions between those tiny um particles up to the atomic level, with the ways that the electrons interact around the atom, and how those electrons connect and bond together to give us all the different laws of chemistry, and how that all falls out just with the interactions of the electrons with the different atoms in different electron configurations around different nuclei, is absolutely mind blowing. It's systems that, on the face of it, look actually quite simple, but are hugely complex and give rise to the great diversity we see in in the world of chemistry, all the different chemical reactions and compounds that we have, and that we're all these different chemical processes that we are reliant on in our modern life come from some what on the face of it looks like some very simple interactions between electrons and atoms, and it's mind-blowing what falls out of something that can look quite simple. Similarly, when we then go, but we go out from there to the world of moving things to planets and galaxies in motion, and how they're all governed by the laws of motion, Newton's laws of motion, and the interactions with gravity and forces. And again, Newton's laws of motion, they are so simple. They look so simple. And yet, the complexity that we have of how we're able to take these mathematical formulas and send spaceships off our planet, perfectly calculate the mass of fuel, the mass of all the things that they need to be to escape the Earth's atmosphere, to then perfectly map that motion of that spaceship round the orbit of the Earth, use gravity as a slingshot and send a spacecraft off to the moon. Or even more, this blew my mind. A few years ago, we sent a space probe, and we calculated, we were able to use these mathematical formulas that govern the way things move. And we calculated the trajectory of this little probe, and we sent it, and it landed on an asteroid far out in our solar system. As this asteroid was coming, or a comet, sorry, a comet was coming in to orbit the sun, and we sent a probe. It landed on this comet. It's in the vastness of space, and the little, let's say little probe, it's not tiny little, and the comet was quite big, but on astronomical scales, that is so impressive, and it was because of the precision of the mathematical formulas that underpin the way things move. And all these things that work together point to a God of order, and a God that is so creative, and that this is where we get our faith-based science, that we can see the hand, the fingerprint of God on everything, whether it be Newton's laws of motion, the laws that govern how things move, whether it be the interactions of atoms that um, and bonding together, or the subatomic world, or the biological world. When we see, I find it absolutely fascinating, and when you look at microorganisms and these these simple organisms, single-celled organisms that are hugely complex. They're like complex machines where which according to atheist scientists, evolved, but that evolutionary process would have required so many systems and so many things to have evolved perfectly in tandem with one another to come together. It's like a machine, like a motor of a machine, that you would, all these working parts have to work perfectly and fit together in order to work together. And if one bit doesn't work or doesn't fit, the whole machine doesn't work. It just falls apart. It just, you won't get a motor. You'll just get some different bits that sit and can't do anything. They need to come together. They need to fit together. And when you look at a lot of biological systems, like little subatomic, little single-celled organisms, they actually have little rotor systems in them. And even on a cellular level, we now know that cells are so complex. They are like little machines. They've got like little motors that, again, these things can't just the idea that they would have to evolve together to perfectly work in tandem, that these different moving parts can slot together, can work together is just is becoming a problem for modern biologists because we're understanding more and more how complex a cell is. And it's mind-blowing the intricacy of these systems. So that is what we think about when we think about faith-based science. It's this teaching of science and the natural world that is underpinned by our faith, where faith is being built up, where we're looking for these hallmarks of a creator. Um, we also believe that our science should not detract from academic rigor. We want to have our teens well educated. We want to raise up teens that can think critically, and can think scientifically. So our iGCSE science classes will, as well as teaching the curriculum to sit the exam, there is that rigor, but there's also that scientific thinking. Part of the curriculum is being able to think about, for example, experiments, different key experiments that are really important to understanding some of these fundamental building blocks of physics or chemistry or biology. And with these, we need to learn how to think scientifically to do good experimentation. So there will be this idea of looking at the scientific method. And for my courses, the iGCSE physics, iGCSE chemistry, I will be giving doable science experiments that they can be done at home. When it's going to be difficult for for experiments to be done at home, we want to be able to do as much as we can practically and have hands-on learning experiences. So there'll be activities which are to just allow you to do something that's hands-on and engaging. There will be experiments which are set up to really test the ability to do the scientific method. And so these will be hands-on experiments to be able to do that. They may be quite simple because we're going to be focusing on this idea of thinking scientifically so that we can set up experiments and think clearly about these. But they will be designed to be done by home educators at home with things that you have in your kitchen. There may be some like a thermometer, something like a thermometer, or kind of little mini accurate scales that can take measurements to quite a smaller degree of accuracy. So that they're things like jeweler scales, digital jeweler scales, which can do that, and they can be bought inexpensively. So there will be a few pieces of equipment that are readily available and not overly expensive that we'll source. But these are all things that are within the reach of your average family. There will be online experiments, so using websites like PhET, which has been put together by the University of Colorado, to do digital experiments that do simulations where we can get real data and see how things work, and then be able to use that data to either graph it or to do calculations with it. So we're learning how to take information and process it. So all these are key skills for working scientifically. Um, with that, the key is to make these classes engaging. So it's not just, even though we're online, they're live classes, they're not you. And with all my live classes, I really try and get teenagers to interact, to talk, to answer questions in class, to discuss things where appropriate. This online aspect to the learning is also going to help make this engaging. So yes, we want to prepare our students for the exam. We want them to do well in their exams, but we also want to teach them to think well, to think scientifically, and for their faith to be their science to be something that builds up their faith, to be able to look at the wonders of God's creation, think, wow, God made that. God is awesome. God is a God of order. He's got the things that he's made and put in place are just mind-blowing in their complexity and their simplicity. I remember when at university studying mathematical physics, something that often came back to me that with mathematical proofs, um, you often know you're coming to the correct answer, or a mathematical proof is true because it is beautiful. Many things are elegant and they look so simple, but beneath them have this layers of complexity that are just they blow my mind every time I think about the way that all these things work together, the simplicity, the beauty, and the complexity that comes together. And isn't that true of the God we serve, that we see in God, we see in Jesus the message of salvation, which a child can understand, but has depths of complexity that we never truly can comprehend this side of eternity. So this year we will be having iGCSE physics, iGCSE chemistry, and we've already spoken about iGCSE biology in another podcast, and there's also iGCSE combined science. So if you have any questions, please don't hesitate to get in contact with us.